to basically how it works today. Once they had chosen Black Canyon as the site of the future Hoover Dam, the first thing they had to do was create a dry spot. Now to do that, they blasted 4 diversion tunnels. 2 on each side through the canyon walls, each over 50 feet in diameter, 4,000 feet long. That alone took almost 2 years. And that's where we are right now, inside one of those original diversion tunnels, right about there. Once they completed those, they came upstream, poured a 100-foot-high earthen dam, the upper coffer dam, forced the water into the tunnels. Then they came downstream, poured a 65-foot-high earthen dam, the lower coffer dam, to keep the water from backing up into the project site. Now all the water traveled through the tunnels. This area dried out, and they were able to pour concrete. Once the dam was completed, they came back upstream, closed off the entrances to all 4 tunnels, allowed the lake to fill. They quickly overcame this dam. That dam is still out there, serves no purpose. The lower dam, on the other hand, they actually had to blast away, so the river would resume its natural flow. Once the tunnels had dried out enough, they went inside, poured 400-foot concrete corks or plugs in each one to seal off the upper half of all 4 tunnels. That area is no longer used. The lower half they left open. Today, there are 4 intake towers on the project, 2 on each side, and they stand in the lake. So the water flows into about the bottom half of each of those and drops immediately into one of these 30-foot diameter penstocks. Penstock is the word we use for pipe around here, and you're standing on top of that 30-foot diameter pipe right now. Now you have some vibration here. It can be much more, and that can signal as much as 96,000 gallons a second of water going directly beneath our feet. And we are again right there on top of that pipe. So these pipes carry the water around the dam, through the canyon walls, and then divert it into 13-foot diameter penstocks, 1 per generator. From the intake tower to the generator, the water drops as much as 250 feet in elevation. It picks up the speed it'll need to spin those large turbines. Having done that, it goes back out into what we call the tail race, or the tail bay, and on downstream. And that's how the dam works on a good day. Any questions on any of that before we head up to the power plant?